Welcome to the Week 4 live session video. This week we have a quiz, a final exam, and the post-test due by Sunday night. And the term ends on Sunday night, so all assignments are due. and so that's it. The final exam, it is cumulative. And this week we do a lot of review over the material over the past 3 weeks. And we do have some new concepts within radicals, so I'll explain those. And what I did was I looked through the exams and quizzes of everyone from the past weeks, and I pull the problems that people have missed the most, and then I'll explain those. So this is a real important live session to watch because of those problems. They're just the most commonly missed in this course. So this is the first one, just a little small problem to start out with. Evaluate -2 to the third minus a -3. So we always use the order of operations if we have some different operations going on. And so first will be exponents. So remember how I teach you how to write your work? This is an expression, so you should write that down first, and then right under it you're going to show how your expression changes. So if you want to take a look at what this is, you take it over to the side like this somewhere. You don't do this in the middle of your work in the next line. If you have to write it out and think about it, that's a -8, so a -8 replaces that, and you write down every other number and symbol right under this. This is going to reduce chance of error for you. This is what I've seen absolutely helps students to get these correct. So now you see what you have there. The next thing is to resolve or evaluate these signs. So two negatives make a plus. So we have -8 plus 3. And this is like you're in debt, $8. And then you add 3 to your account. So you're still in debt $5. And so the answer is -5. And the next problem, this is another commonly missed problem. So see what you've got here? You have a big polynomial minus another big polynomial. So the key thing here is to remember that this right here, since you have a negative sign, if it's an addition, it's not a big deal. Students don't tend to miss that problem. But if there's a minus sign, it's a very commonly missed problem. And this is a minus sign that should be considered as a -1 that you distribute to each term inside the parentheses next to it, which is to multiply. So what I have to do next is to write what the problem looks like. So parentheses really aren't necessary for this one, so I'm just going to drop the parentheses around these terms. So my brain needs to see what the problem looks like now. So -1 times 7x to the 5th is -7x to the 5th. -1 times -4x to the 4th is plus 4x to the 4th. -1 times -2x to the 3rd is plus 2x to the 3rd. -1 times -4 is +4. So basically a -1 changes the signs of all these terms. So after doing a lot of those, you can just write that down really quick. But this line right here, see, I have the original problem written, which is what you should have written. This line is very important to write down. Students who miss the problem 100% of the time do not write this line down. So I'm checking my signs, and so what we need to do next is check for like terms. So remember, the exponent kind of names the type of term it is. This is the x to the 5th term, so that one's like this one, x to the 5th. So I'll underline those so I know to combine those. X to the 3rd terms are right here and here. We have an x to the 4th term that's by itself. And then we have numbers that are like -4 plus 4. That's actually equal to 0, so those kind of just go away. And I'm going to underline this one kind of by itself, just so I don't forget it. So my next line, I'm going to combine my x to the 5th terms. 4x to the 5th minus 7x to the 5th is -3x to the 5th. So a good thing to do since you have a lot of terms is cross those out so you know you used them. Then going in descending order of exponents, we've got plus 4x to the fourth next. So I used that up. Now I have negative 3x to the third plus 2x to the third, so that's minus one of those. We don't really write the 1. And cross those out. And this way I see that I used everything. Now I've got a fifth, x to the fifth term, and x to the fourth term, and x to the third term, and that's it. That's the answer. And I know precisely that's correct, or at least I'm confident, because if you practice a lot of these, that's going to help you. And also just remember this key thing. This is the number one reason students get this incorrect, is they don't realize there's a negative 1 they got to distribute, and so then they get these signs wrong of these terms. The number 2 reason, which is probably the number 1.5 reason, is that they don't write this line down so you can really see what you've got there. So that was so important that I have another one of those. So you can stop the video or pause the video here and try this one and see how you do. Otherwise, I'll show you how to do it. So the thing to identify is I've got a lot of terms here minus a lot of other terms, polynomial minus another polynomial, and this subtraction sign's key. I have to remember that's a negative 1 that I have to distribute to each term inside the parentheses to the right of it. So the next step is to write down what the problem looks like. Now, so negative 4y to the third plus y squared minus y minus 3 plus 2y to the third plus 3y minus 2. So now I'm looking for my like terms. So I've got y to the third terms here and here. And then I have a y squared term by itself. Then I have y terms right here and here. And then I have numbers right here and here. So however you want to identify those, you can do that. So negative 4y to the third plus 2y to the third is negative 2y to the third. So I use those. Then I have the y squared. I can't leave that out. Then negative y plus 3y is plus 2y. The negative 3 minus 2 is negative 5. And that's your answer. In the next problem, there's this question that I've seen that students seem to get confused about what they're asking for. X equals 3 and x equals 1 are solutions of the equation x squared minus 4x plus 3 equals 0. Is this true or is it false? So it's a true-false question, and we're focusing on this equation, x squared minus 4x plus 3 equals 0. So they're asking if these two things are solutions of this equation. So what you do first is take this solution, supposed solution, x equals 3, and we're going to put plug 3 in everywhere we see an x into the equation, right under the equation. This is how I'm writing it, right? Here's the original equation, right under it I plug in 3. Everywhere I see an x, and then we evaluate and see if we have a true statement. So 9 minus 12 plus 3 equals 0. This makes negative 3 plus 3 equals 0, and so 0 equals 0. That's a true statement because you're going to have the 0. That's simplified. The right side is simplified, so you just carry that down all the way. You're just simplifying the left side. But we do get a true statement, so we know x equals 3 is a solution to that equation. But that doesn't mean the problem is true or false yet. We have to still check the other value of x that we're given, which is 1. So we also plug that one in everywhere we see an x separately. And simplify this side. So this will be 1 minus 4 plus 3 equals 0. And this makes negative 3 plus 3 equals 0. 0 equals 0. So that's true as well. So that means this is true. Since both solutions check out, it's true. If neither of the solutions check out, of course the answer is false. But if you get a problem where one of them check out and the other doesn't, whichever one, if just one of them doesn't check out, of course the answer is false. They both have to check out for the problem to be true. But that's how you do that. Now we have an inequality that's similar. The solution of x minus 1 less than negative 4 is x is less than negative 3. True or false? So we write down the inequality that we're given. And then we're going to plug in negative 3. No, we're not going to plug in negative 3. This isn't an equation. So what we do is realize that this is inequality. So this solution set here says that all x values are less than negative 3, not including, there's no equal part here. So it doesn't include negative 3. So we can't even use negative 3 as a test point. So we have the inequality. And if all x values less than negative 3 are solutions of this thing, then any value less than negative 3 can be plugged in here. So I'll think of a value less than negative 3. I don't know, negative 4. You could do negative 100. Anything less than negative 3, plug in here. Anything. And we're just going to see if we get a true statement. So this will make negative 5, and we have negative 5 is less than negative 4. So is that a true statement? Is negative 5 less than negative 4? And you can look on a number line if you want. The answer is yes. So this is true. All solutions of this are where x is less than negative 3 are solutions of this inequality. So you can pick another test point if you want. I should fill that in. I hate filling in bubbles, so I just crossed it. So the answer is true, okay? So you just pick one value and plug it in. And you can do a couple if you want. The next problem is where we have 4x minus 3y equals 6. And we're asked the slope of the line is what? And remember, slope of a line is a number value. It could be positive, could be negative. No x in there. There should not be x in your answer. You probably will get multiple choice. So the key is to put this into y equals mx plus b form. Sorry about my throat. And this is the slope value right here, m for slope. So once we rearrange this equation, we can read the coefficient right off of there. And we can tell what the slope is. So I need to take 4x minus 3y equals 6 and get y by itself. So I'm going to subtract 4x from each side. I'm going to make the 4x disappear from the left side and appear on the right side, so it goes away from y. So subtract 4x from both sides, because this part will be 0, and 0 minus 3y is just minus 3y. That's how we get rid of that 4x on that side. So at least 4x is on this side. Now I need to get the negative 3 away from y. I'm going to bring this up over here. So negative 3 is being multiplied by y, so I'm going to do the opposite operation and divide by negative 3, and I have to do that to each term on this side. Then I write down what we have. And these cancel because that equals 1. 1 times y is just y. 6 divided by negative 3 is negative 2. And negative 4 divided by negative 3 is a positive, so we have plus 4/3 x. So just to write that in y equals mx plus b form, I'm going to switch around these terms. And you can see the slope now, right here, 4/3. So 4/3 goes right here. Now we have a question that says, write the equation of the line that passes through the points negative 3, negative 2, and 0, negative 3. So you need an equation of a line. Your answer is going to be something like y equals mx plus b, or probably something with a y and an x in it. So we would need to find the slope and the y-intercept there. B is y-intercept. We're given 2 points. Anytime we're given 2 points, I know that I can calculate slope. So I'm going to pull out of my toolbox my slope formula. And right under it, I'm going to plug things in. I'm going to write the division bar that comes with the formula and the subtraction signs that come with the formula. Now the y's go in the top, so the y's are -2 and -3. So I'm going to plug those right in. Since there's two signs next to each other, put parentheses. Just good penmanship to do that. And then the x's go in the bottom. The x's are -3 and 0. And so I'm going to simplify this. That makes -2 plus 3. My brain needs to see that, so that's all I'm going to do in that step. And then the bottom's -3. And then I'm going to take this up here, still working on just finding the slope. -2 plus 3 is 1, and then I have 1 over -3, and that's the same thing as -1/3. So my slope's -1/3. So I can write my answer right here if I want. -1/3 will go in here for m. And I've got to figure out b. It's going to be plus or minus. There's a couple ways to figure out what goes here. I'll use y equals mx plus b, this equation that most students tend to use. But we know the slope value is -1/3. We need to find this. So we also know y and x because we're given two of these points that are on the line. You can use either of these points and you'll get the same b value. I'll use this one, I suppose, 0, -3. So -3 in for y and 0 in for x. That'll make -3 equals 0 plus b. Looks like -3 equals b. So -3 goes right here. And there's my equation on my line. You'll have multiple choice so you can see what kind of format it's in. In the next problem, what I meant here was we're given a graph and we have to find the equation of the line just by looking at the graph. So you have to look at what we know there. And if you're to come up with an equation of a line ever, I always write down some form of an equation of a line, like y equals mx plus b, and then I start to think of what can I plug in. Like, b is real easy. All you got to do is look at where the line crosses the y-axis, because that's the y-intercept, which is right here at +2. So I know the equation of my line has that. The equation of my line also will have y and x in it. Y and x stay as unknown variables, or just you could think of them as variables. They vary because all these points that make up this line vary, that the y's and x's are all different along the line, but what's constant about the line that will never change is that it always crosses the y-axis there at 2. Another thing that will always be constant is the way it's sloped. And the way it's sloped is described by m. So we need to figure out the slope, which is not too bad. We need 2 points, right, to figure out slope, and then we can use the slope formula and find that value of slope. Well, I've got a point right here at the y-intercept. All I need to do is find a real clear point somewhere where this crosses the crosshairs. Either I can use this right here, or I can use the x-intercept, either one. I'll use the x-intercept because that involves a 0, because the coordinates for that is -3, 0, and that's easy to calculate when you have zeros in there. And over here we have 0, 2. So for my slope calculation, I'm going to put the slope right in here, the slope value, when I find it. So this will be my answer. But my slope calculation will be right here. Here's my slope formula that I write down first, remember? Write down the formula first, right under it plug things in. So m equals, here's the division bar that comes with the formula, the subtraction signs that come with the formula. Now my y's go on top, 0, 2, so 0 and 2, and my x's go on bottom, -3, 0, just like this. And then I'll just simplify this, -2, over -3, and that looks like 2/3. So 2/3 goes right in here. So this is the equation of my line that I'm looking at on the graph. See, that's how we come up with an equation of a line. We drew a line and just analyzed the heck out of it. What do I know? How can I put that into an equation where I algebraically represent it? And then we can do so much with that with real applications. Now, I have no idea what I wanted to do here, so we'll skip that. Here is a graph where you'll be given a graph and you have to come up with the equation of this, or obviously they're shading, so it's an inequality. So we're going to have an inequality of some sort. You know, it's going to be like this, or it's going to be this way, and maybe it'll have an equal part, and then mx plus b. So that's going to be what our inequality will look like. But I already can piece one thing together. There's not going to be an equal part to our symbol because there's a dotted line. If there was a solid line, we'd have an equal part. So at least I know that much, but I don't know which way it is yet. And then I know I'm going to have a y and an x in there, remember? So equations of lines usually have a y and an x in there, but my m and my b need number values. So remember, the b's are real easy to find. You're looking at your boundary line, and this goes through 2 again, positive 2. So our inequality is going to have plus 2 right there, x here, y here, some sort of inequality sign and some sort of slope. I should probably move this up a little. So let's figure out slope. Remember how we did that before? Pause the video and see what slope value you get, and see if you get the same thing as I do. So let's take a look at how to find slope. I know one point here on the line is at 0, 2. I need find another point to find slope. So remember the x-axis, the x-intercept rather, is good to use because there's a 0 in that. And you can also use some other point you find at crosshairs too, you know, anything, but this I like to use because it has a 0 in it and it's easy to calculate. So I'll use these 2 points to find my slope. First, I write down my slope formula. Did you do that? And then right under it, I plug things in. Did you do that? Write down the division bar that comes with the formula, the subtraction signs that come with the formula. Then my y's go on top, 0 and 2. My x's go on bottom, -4 and 0. And just simplify this. -2, -4. That's 2 over 4, which is 1/2. So 1/2 goes into my inequality right here and place this slope. Now I need to figure out which way to shade that, or which way to shade, which way to put the symbol. And then I've got my answer. So what I'm going to do is I'm going to pick this way and see if that works out. Y is greater than 1/2 x plus 2. And so what I'll do is pick a test point which is in my shaded region. I'll pick 0, 0 because that's always easy to calculate. That's in my shaded region. So 0, 0, that's the coordinates of that point right there. X is 0, y is 0. So I'm going to plug that in and see if I get a true statement. If I do, I know that the symbol should go this way. It represents this side of shading. If I don't get a true statement, I know I need to put the symbol the other way in my answer. So when I simplify this, I have 0 is greater than 0 plus 2, and 0 is greater than 2. So is that true? Is 0 greater than 2? And of course that's no. So that just means the symbol should go this way, pointing to the y. See that? And so that's my answer. This is how I piece that together. Just by looking at the graph, I can come up with the inequality for that. In this next problem, a lot of students have trouble with this. Find f of x equals -x to the third plus x squared plus x, find f of negative 2, sorry. So first thing is to recognize this is not really f times x, just know what this notation means. This says function of x. That just means that this equation here, this stuff, really is a function, it's usable. And we want to find f of negative 2, and in that f of x notation, that negative 2 is in the x spot. So that means we're going to plug in negative 2 everywhere we see an x into this equation. But we have to make sure that we write down every symbol and every other number that comes with that. So I'm plugging in negative 2 everywhere I see an x, just replacing it. Use parentheses just because there's two signs next to each other. So negative 2 is cubed, and that negative's outside here. Negative 2 is squared, so I use parentheses because we want to show that all of this negative 2 is squared. And then negative 2 here is in parentheses because there's two signs next to each other. And then you just simplify this. So this part, we do exponents first. So those are exponents here. So this is negative 8. But this negative comes down with it. I got two signs next to each other, need parentheses. Plus negative 2 times negative 2, that's a 4. Positive 4. And then I'm going to leave this here to do in the next step. So now we just need to evaluate or resolve these signs that are next to each other. So two negatives make a positive, 8 plus 4, and then this makes a negative, or minus 2. So you can see what you have there. So that's 12 minus 2, and that's 10. So your answer is 10. So f of negative 2 equals 10. In the next problem, you're given a graph and you're asked to estimate a value. Now, I came up with 3 different problems here for this one graph so we could practice. So f of negative 9 equals what? There's going to be a number value answer right here. So what you do is you first recognize that this negative 9 is in that x spot. That means go to negative 9 on the x-axis, which is right here. Okay, and since that red graph is up above it, you go to where that hits that graph, and then we're going to read where that is on the y-axis, and that's 1. So 1 goes right here, and that's the answer. It's actually very quick and easy, but you have to know what you're doing. It's not intuitive. So next is f of 3. So 3 is in the x spot. So you go to 3 on the x-axis. I'll do this in a different color. So 3 on the x-axis is right here. And we're going to go up because our red line is up. You're going to see where that hits there. And then you're going to read where that is on the y-axis. And that happens to be 3 as well. So 3 goes right there. That's the answer. Now you try this one, f of 0. And I think it was in the week 3 live session video, I did 2 of these, so you should go see that video as well, and you can fast forward to find that part. So you try f of 0, see what answer you get. So what we do is go to 0 on the x-axis, which is right here, and you go to wherever that line hits the graph, the red line is, it's right down here. And you read where that is on the y-axis. It happens to be right on the y-axis at negative 3. So negative 3 is the answer. You'll just have a graph and you'll be asked one value, just one of these. So grab up those points. You probably can hear my dog snoring. Next we have a system of equations that you are to solve. And what happens is we're trying to find the point of intersection of two lines. So the top equation represents a line, the bottom equation represents a line, and those two perhaps cross. Sometimes they don't, and they're parallel, but if they cross, there'll be a point of intersection, a point they have in common, and we're always trying to find that point, x and y coordinates of that point, so our answer will be right here. So basically we're solving for x and we're solving for y. And I think I explained this in the previous video as well at the end. So you can solve this by using the substitution method or the addition elimination method. So what I'll do here is use, I'll use the addition and elimination method. So what you want with the addition elimination method is that your x values are lined up, because you're going to add these down the column. So they're lined up, the y's are lined up, and the numbers are lined up on the other side of the equal sign. This problem happens to be already set up like that, so that's good. The next thing you want is that the x's will add up to 0, or the y's will add up to 0, one or the other, and if both do, that's okay. So if I add negative 2x plus 3x, I'll get 1x. If I add plus y minus 2y, plus y plus m minus 2y, that's a negative y, so neither are going to add up to 0, so that's not good. We need to make that happen. So what I'm going to do is write down my system. Well, actually, I should write down the lower equation first. So I'm going to write down 3x minus 2y equals 4. So what I'm going to do is I'm going to multiply this top equation by 2. And that means I'm going to multiply each term by 2. I'll show you why in a second. So 2 times negative 2x is negative 4x. 2 times y is 2y. Equal sign, 2 times negative 2 is negative 4. The reason I picked 2 was because I saw this negative 2. See what happens when I add the y's? When I'm going to go and add these, those add up to 0, so that's good. I had to make this happen, but I have to multiply whatever I choose by every term, or else I'm changing the whole equation if I only multiply by one term. So that's why I picked it too. So sometimes you have to make it happen. So now I'm just going to go ahead and add these down. Negative 4x plus 3x is negative 1x. We just write it like this. Plus 0 equals, and this happens to add up to 0 too, and that's okay. Negative x plus equals 0 actually just means x equals 0. So I got my x coordinate right here. Now I need the y. So you can pick either one of these original equations to find the y. I'll choose the bottom one, what the heck. 3x minus 2y equals 4, and I found that x is 0, so I'm going to plug that in to find my corresponding y value. So that makes 0 minus 2y equals 4, which is really negative 2y equals 4. And I'm thinking negative 2 times what equals 4? That has to be negative 2. So that means y is negative 2, and that's my answer. We're trying to find that point of intersection. Now we're looking at radicals. I think I worked some things out here already, so I'll just describe what I have here. So we know something about square roots. You know, radicals are square roots. It doesn't have to be square. Sometimes they're third roots or fourth roots or something, but so that's why I just call them radicals. So if we start with square root of 36, we know the square root of 36 is 6. That we're familiar with that, right? Square root of 49 is 7. Square root of 25 is 5, square root of 9 is 3, square root of 4 is 2, square root of 100 is 10. Those numbers are called perfect root numbers because we can come up with the answer, I guess you could say, without having explained it further. So the square root of 36 is 6 because 6 times 6 is 36. Square root of 49 is 7 because 7 times 7 is 49, or 7 squared is 49. 5 times 5 is 25, or 5 squared. 3 times 3 is 9, or 3 squared. So square roots are the opposite operation of exponents, at least squaring. So what we can do, one way that I just rewrote this, square root of 36 I rewrote as 6 times 6. Anytime you see two numbers that are the same, you take one out, and that's your answer. So square root of 49, I rewrote 49 as 7 times 7. So anytime you have two of the same like that, you take one out, and that's your answer. just a way to look at that. So just to start off with something we know, which is these basic square roots values here. So what if we have square root of 48? Now 48 is not a perfect root number, but you might be asked to simplify this radical. So you can't just pull out your calculator and push it in, because you'll come up with a decimal value. And we do have that in some math courses, but I don't think we do that in this one. So we have to actually simplify this where we'll have a radical in our answer. But what we do is think of two divisors or factors of 48 where one is a perfect root, and you want the biggest perfect root number possible within there. So when I see 48, I always think of 6 times 8, and that's good, but neither 6 or 8 are perfect root numbers. So if I could think of, I could work with that, but if I could think of other divisors of 48, like 48 is made of 16 times 3, so I'm going to rewrite 48 this way. 16 times 3. If I can, realize that, 16 is good to use because that's a big perfect root number. We know the square root of 16 is 4. What you can do is give each its own radical. This is one way to look at it. Writing out radicals and problems, and there's different ways to do it. So you can give each its own radical. Square root of 16 times square root of 3 is the same thing as putting it under one radical, as long as it's multiplication. Okay, because this represents 48, it's just the same thing. So I know square root of 16 part is 4, so I'm going to replace that with 4. Square root of 3, I can't simplify, so that's it. 4 root 3, or 4 square root of 3. Square root of 48 reduces to 4 square root of 3. And what do I have on the next slide? Okay, so what I'm going to do is another problem like that, which is a square root of 20. So say you have to simplify square root of 20. 20 is not a perfect root number, so I have to think of two divisors where one is a perfect root number, if there is any. Sometimes there's not, and that would be like the simplest that you could get. So we know 10 times 2 is 20, but 2 is not a perfect root number, neither is 10. But 4 and 5 would be good to use. So I'm going to replace 20 with this, what is equivalent to, because 4 is a perfect root number. I know the square root of 4 is 2. So I can give each its own radical, and then identify this as a 2, because square root of 4 is actually equal to 2. And square root of 5, there's nothing we can do with. So that's it. The square root of 20 is equivalent to the square root of 2 square root of 5, or 2 root 5. And that's the process for simplifying radicals with the numbers under it like that, where it's not a perfect root. Now we start to look at unknown variables. So if you have the square root of x squared, so if we don't have a number written in this index or root number area, we do assume that it's a 2. Like, there's really a 2 right here. We just don't write it as shorthand, but we call it square root. There's really a 2 right here. So I wrote it here just to point it out. There's really a 2 there. So I wrote it here to point that out too. We usually don't write it, but that tells us something. So if we have x squared, we can write out x, those two x's within x squared. This is the same thing as x squared. And since we have a 2 here, that tells us we're looking for pairs of things that are the same. When we have a pair that are the same, we take one out. So the square root of x squared is equal to x. And here we have the square root of x to the 4th. You might be asked, what's to simplify the square root of x to the 4th? So a good thing to do, especially when you're starting out, is to write out 4 x's. So I did that here. Here's 4 x's. And there's that 2 right here that tells you that you're looking for pairs of things. So I underlined a pair here. For every pair of x's that you see, you take one out. So for this pair, I took out 1 x right here. And then here's another pair of x's, and I took one out right here. And of course we multiply what comes out as x squared. So the square root of x to the 4th is equal to x squared. So next we'll look at square root of x to the 6th and simplify that. So if you write out 6 x's, you're looking for pairs of things because there's a 2 right here. For every pair, you take one out, so that's one x that'll come out. There's 2 x's that'll come out. There's 3 x's that'll come out, and that's x to the 3rd. So 3 x's multiplied together is x to the 3rd. Now what if we're simplifying the square root of x to the 3rd? So there's really that 2 right here. So we write out 3 x's. And so we're looking for pairs of things because there's a 2 in our index or root number. So here's a pair of x's. So we take one out, which is right here. And this one is extra, it's like left under. So we leave that under. So the answer is x times the square root of x. Sometimes you have leftover. We didn't have any leftover left under a radical with these, but we do sometimes. So that should give you a start. You also have a couple unknown variables under one radical, and you just look at one at a time. So x to the 4th times x times y squared. We're trying to simplify the square root of x to the 4th times y squared. So one thing you can do is write out 4 x's. You don't really have to write those dots. You just writing it without dots, you know it's multiplication. And 2 y's. And remember there's a 2 here. So we're looking for pairs of things. For every pair, we take one out. So an x comes out, another x comes out, and then a y comes out. Oops. I guess they all go to the same thing. And then a y comes out. So that means x squared y is my answer. Now we're looking at the 3rd root of x to the 6th. So you just do the same thing. Write out 6 x's. Now if I had to write out 100 x's, this would get ridiculous. So you don't always have to write them out, but you'll start to see a pattern after you do these. 1, 2, 3, 4, 5, 6. 6 x's, but there's a 3rd root here. So this means we're looking for a set of 3 things that are the same. For every set of 3, you take one out. So 1 x comes out, 2 x's come out, so x squared is your answer. Nothing's left under. And if you notice, 6 divided by 3 is 2. So let's see how this one works out. The 4th root of x to the 6th. So I'll write out 6 x's. 1, 2, 3, 4, 5, 6, and I've got a 4th root here. If I don't write that 4 in, I'm saying it's a square root, a 2's in there. And we were given a problem with the 4 in it. So we can't forget that and change that. We actually have to write it in if it's not a 2, and it's another number than 2. We have to write it in. That tells us how many we're looking for in a set. So I'm looking for a set of 4 of the same thing. For every one set, we take one out. So an x comes out for that, and then right here I like to circle what's left under. That's just left under. And it's under a 4th root, and there's 2 of them, so I just go ahead and write 2. You don't write x times x. So the answer is x times the 4th root of x squared. Now if we look at a number again, we can break down 8 into its prime numbers. We know 8 is 4 times 2, really 2 times 2 times 2. And so we're looking for a set of 3 things that are the same. We do have that. For every one set, we take one out. So the 3rd root of 8 is 2. So it's the same procedure whether it's unknown variables or numbers. It's just with numbers we can break it down into its prime values. That's one way you can do it. Let's see what other types of problems you'll see. We have 5th roots, we have 6th roots, we have all kinds of roots. So you're looking for a set of 5 things that are the same, right? So you can start to see that without writing it out. But we'll write it out, 3 x's and 7 y's. And we're looking for a set of 5 things. We don't have that within x's, but within y's we do. For every set, we take one out. So I'm going to write that here. So it looks like a y comes out. And we have this left over, 3 x's and 2 y's. So you just write what's left under the radical, under fifth root. Don't forget the fifth root. Now, if you have multiple choice, I guarantee you there'll be a square root choice, answer choice, or nothing will be written there. So, which means there's a secret 2 there. So just be careful of that. It has to be under a fifth root. So you have 3 x's left and 2 y's left. So that mess is your answer. Now you might want to pause the video and try this one, see what you come up with. So this answer is actually just y. So here's the reason for that. You got 5 y's. We're looking for a set of 5 as it happens. Here's a set of 5. For every one set, you take one out. And there's nothing left over, so that's it. And 5 divided by 5 is 1. There's really a 1 right here as an exponent. But anytime the exponent's the same, like this, or the exponent is the same as the root number, that's how it'll work out. Just the y. Sort of a short problem there. Third root of 8 we already did, and that was 2, remember that? Because 2 times 2 times 2 equals 8, and we're looking for a set of 3 things that are the same. So what if we had negative 8? So what we're looking for, is there 3 numbers that you can multiply like this that are the same number that equals negative 8? Is there a way to rewrite negative 8 in that way? So we can by writing negative 2. Negative 2 times negative 2 times negative 2 really legitimately does equal negative 8. So this is replaced in negative 8. And we're looking for a set of 3 things that are the same, and for every one set you take one out. So the answer is negative 2. So sometimes you can have a negative answer, but actually it has to be an odd index number for that to happen. But you can just write it out and think and see if you can come up with that. So what about the third root of negative 27? You could pause the video and see if you can come up with the answer for that. So what we would be doing is looking for a number that is the same number that when we multiply it 3 times it equals negative 27. And that is negative 3. Negative 3 times negative 3 times negative 3 is negative 27. So we're just first step replacing negative 27 with what it's equivalent to. And then we just think about how we're looking for a set of 3 things that are the same. For every one set we take one out. And there is negative 3. Negative 3, negative 3. So the answer is negative 3. Just a few more problems left. So how about the fourth root of 64? So what we would need to do is to break down 64. You can do like a little factor tree if you wanted. We know 64 is 8 times 8. I always think of that first. This is made of 4 times 2. This one's made of 4 times 2. This is 2 times 2. And this is 2 times 2. And the roots are 6 2's. 2 to the 6 basically is 64. So I'm going to rewrite 64 as those 6 2's so that I can see them. So this represents 64. So I replace 64 with this. It's equivalent. So we're looking for a set of 4 things that are the same. For every one, we take one out. And this is left over. So that would be left under a 4th root as a 4. 2 times 2 is 4. 2 times the 4th root of 4, and that's it. Isn't that weird? But use the same thought process. Now if you have a problem like square root of 45x to the 6 times y to the 7th that you've got to simplify, there's this 2 right here, square root. We're just taking the square root of these things. So 45 is not a perfect root number, but we can think of 45 as 9 times 5, because 9 is good, it's a perfect root number. And then you have x to the 6th, y to the 7th, and you can write out 6 x's and 7 y's if you want, because we're going to be looking for pairs of things that are the same. There's 2 3's within 9, so you're going to be taking out the 3. The 5's going to be left under, can't do anything with that. There's 3 x's that you can take out. Anyway, 6 divided by 2 is 3. And we've got to consider how many y's we can take out. So if you want to write out 7 y's, do that, but you'll start to see this a bit faster too. And we're looking for a set of 2 things that are the same. So there's 3 y's that can come out, but 1 y is left under. So a 5y is left under square root. So you got to make sure this 3 does not look like it's the index number here, because that's actually a square root. So a 5's left under and a y is left under, and you'll probably have multiple choice. So you can be careful and identify what the correct answer is here. A different type of equation, a problem is this equation, a radical equation. So the first thing you do is write down your equation, square root of 2x plus 4. This is really kind of different than what we worked with radicals. We're solving for x. We want to see in the end what value that x represents, what number value. Maybe there's 2 values, sometimes there are. So we want to get that, we want to get 2 away from x, we want to get 4 away from x, and that radical, that x needs to get out from under the radical. So we actually deal with the radical first. It's a square root. So we do the opposite operation of square root, and that's to square. And we have to do that to both sides. What happens when you square the square root of something is this stuff just underneath the radical just comes out. And then over here we have 16. Now you have just a nice equation to work with, which what we're going to do is subtract 4 from both sides to start with. So we have 2x equals 12. And we know 2 times 6 is 12. So x is 6. The thing with radical equations is you must check your answer, because more than any other type of equation, a solution that seems like a solution to radical equation will not work out. So what we have to do is take the original equation, square root of 2x plus 4, and my internet will not let me make nice looking numbers here. And we found that x is 6, so we're going to plug that in and see how that checks out. So we got 4 on the right side, so I'm going to see what the left side simplifies to. This is 12 plus 4 under a radical. That's a square root of 16 equals 4. And that's 4. And that happens to be a true statement. So I know that this is the correct answer. If I don't get a true statement, something like 1 equals 4 or 0 equals 4, anything untrue, then the answer will be no solution. Now, we have in this week some weird problem where we have i's. I is an imaginary number. I love imaginary numbers. They're so neat. But they're just not real numbers, and we only do one little thing in this course with imaginary numbers. There's a bit more we can do with them, but this allows us, i's allow us to work with numbers that are not real. And believe it or not, we do have real applications in circuitry, I believe, with imaginary numbers. So here's a definition, that I squared equals -1. This is just something we've defined so that we can work with imaginary numbers. Just remember that anytime you see an I squared, it equals -1. So we have a problem here, -2i times 6i. So it, as far as evaluating this, is very similar to as if these i's were x's. So you take -2 times 6 and you get -12, and I times I is I squared. Now remember, I squared equals -1, so you have to replace I squared with -1. So you have -12 times -1, which makes a positive 12. So that's this problem. That's how to work those. And that's really all we're doing with those. Now we have what we call a quadratic equation. I think I've got a couple of those and then that'll be it. So you can solve quadratic equations about 4 different ways. And I'm going to show you using the quadratic formula. You can always solve them with the quadratic formula. So one way is to solve them by factoring, but not all quadratic equations are factorable. But if you use the quadratic formula, you'll always be able to use that. So I'm just going to practice that. So we have a basic quadratic formula. This is just what's called a quadratic formula, your classic trinomial setup, but equals 0. Ax squared plus bx plus c equals 0. So you can see our a here, our b is a coefficient of x there, our c. So what we have to do first when we're given an equation is identify what our a, b, and c are, write these down, because we're going to plug that into our quadratic formula. This is the quadratic formula. Now there's a lot of YouTube videos, there's a lot of instructors explaining how to do this. You just need to go and search for solve an equation or solve a quadratic equation using the quadratic formula. Anything like that, and you'll find instructors explain it, but I'll also explain a couple problems here. So we plug in a, b, and c into this formula, so we need to figure out what our a, b, and c are out of this. So see, a is right here, that 6 is in that a position, so a is 6. -1 right here is in that b position, so we got a -1 for b. C is -15. And so now we plug things in right under it. This is where there's a lot of error. This is one error spot, popular error spot for students. It's just easy to make a careless mistake. So make sure you got your signs correct. And then I'm going to write the division bar. And then I'm going to write every symbol if the internet will let me, because when my internet is slow or something, that's when I make silly symbols. The negative sign there, the plus and minus, the square root, -4, all that comes with the formula. So now b is -1, so -1 goes right in place for b. See that? And I gotta put parentheses. And then I have b squared, so -1 squared minus 4 times a times c, so that's 4 times 6 times -15. And then 2 times a down here, which is 2 times 6. Now I'm going to simplify that stuff. The bottom's always the easiest, that'll be 12. -1 like that makes a +1. Plus minus the square root of all this stuff. So -1 squared is 1. Now I've got -4 times 6 times -15, so that's going to be a plus something. So you can take your calculator and figure out what 24 times 15 is. Which is 360. And I'm going to take this up here. So x equals 1 plus or minus the square root of 361. I don't know if 361 is a perfect root. I'll check with my calculator. Square root of, oh, come on. Happens to be 19. So I have x equals 1 plus or minus 19 over 12. So I have to simplify this in this way. I'm going to take this and make a new slide. Okay, so I have x equals 1 plus or minus the square root of 19. No, not the square root, just 19 over, come on now, 1 plus or minus 19 over 12. So that means I have x equals 1 plus 19 over 12 to work out and simplify. And I also have x equals 1 minus 19 over 12 to work out and simplify. So 1 plus 19 is 20 over 12. So I just need to simplify that fraction. So 20 divided by 4 is 5. 12 divided by 4 is 3. So 5/3 is one solution. Then I have negative 18 here, 12 here. Looks like 6 will go into each. 18 divided by 6 is 3. 12 divided by 6 is 2. So negative 3/2 is another solution. So that's how you solve that quadratic by using the quadratic formula. So we'll do another one. Remember, ax squared plus bx plus c equals 0 is your basic quadratic. And if you want to pause the video and try this yourself, you should do that. I need to find out what my a, b, and c are, because I'm going to plug that into my quadratic equation, which I always write first before plugging things in. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Then right under it, I'm going to plug things in. I'm going to write down the negative sign that comes with the formula, all of these symbols and numbers that come with it. Okay, so my a is 2, my b is a positive 3, my c is a negative 3. So b goes right here, which is 3, and then b squared here is 3 squared. Then 4 times a times c is 4 times 2 times negative 3. And then 2 times a is 2 times 2 right there. So I'm going to simplify now. The bottom's always the easiest. You have a 4 there. So negative 3 plus or minus the square root of, this makes a 9. Then I have minus 4 times 2 times negative 3, so that's going to be a plus 8 times 3 is 24. See if I can squish this in here. X equals negative 3 plus or minus the square root of 33 over 4. And this doesn't simplify anymore. I think that's what your multiple choice answer would look like, and that's it. Which actually represents a couple decimal number solutions. But writing it this way shows exactly what you have there. So I think that's how the Blackboard program will show your answers. And that's all the problems I have to go over for today. Remember, by Sunday night you have quiz 4, final exam, and the post-test due. Those are all for a grade. You also have YouTube videos in my math lab for help. So that's it, guys. Good luck, and I'll see you in class.